Hello everyone, welcome to SS Educare Teaching Learning channel. Thank you for all my subscribers. Those who are watching my videos without subscribing, please subscribe and watch my videos. Your support is my strength. Let's go to our channel. Scientist of the day. This scientist was called the genius of the world. This scientist was awarded Nobel Prize for his great invention on theory of relativity. This scientist could not speak even after 3 years. When the scientist was born, there was no electricity in the houses. This scientist, when he was in teenage, was in love with a girl and he married that girl also. This scientist got his first job in patent office as examiner of research papers, which was the turning point of his life. With this interest, he was a poor student in the school, but still he had a good passion for mathematics and science. With this knowledge, he found out theory of relativity. Yes, the scientist was none other than Albert Einstein. Einstein once said, "Education is not just learning of facts. It's training the mind to think." Einstein also said, "Creativity opens the door of imagination. Imagination leads to invention." That's the scientist of the day, Albert Einstein. Welcome back to the channel. In our today's video, we will be solving numericals of chapter 1, force. I will be doing each and every problem along with given statement and the formulas. Before going into the numericals, let's discuss about only 3 formulas which are there in this chapter. Formula number 1. Look at the picture seen here. The picture has 2 ends where one end is pivoted and the other end is free. The green color arrow mark shows the forces and red color arrow mark denotes the perpendicular distance. Yes. So what is formula 1? It's tau is equal to F and R. F is your forces multiplied by R is your perpendicular distance. Formula number 2. It is your couple. Look at the picture. We have 2 points A and B where 2 forces acting in opposite direction. But both the forces are rotating clockwise only. Then, so what is couple here? The couple is equal to either of the force. When 2 forces are acting, we will take either of the force into consideration into couple arm. Couple arm is its perpendicular distance only. That is formula 2. Formula 3. Formula 3 is principle of moments. When 2 forces are being taken, and 2 perpendicular distances are there, we will write the formula as F1 into R1 is equal to F2 into R2. Then, if weights are being given in the question, W1 into R1 is equal to W2 into R2. In general, we will say principle of moments is defined as the sum of clockwise moments is equal to the sum of anti-clockwise moments. That's the three formulas on which we will be solving the numericals of this chapter. Let's go on to numerical number 1. The question is displayed here. I will be reading out the question and then I will solve it for you. Question number 1. The moment of force of 10 Newton about a fixed point O is 5 Newton meter. Calculate the distance of the point O from the line of action of force. Let's see what is given in the statement. Given is force, that is your 10 Newton. Your moment of force is given in the question, that is 5 Newton meter, and they are asking us to find out perpendicular distance. According to the formula, tau is equal to force by its perpendicular distance. What is moment of force here? Moment of force given is 5, that is equal to your force into your perpendicular distance. You have to find out R. R is equal to 5 by 10. What will be you will be getting 0.5, and what is the unit of distance? It's your meter. So this is how you will calculate perpendicular distance. Question number 2. A nut is opened by a wrench of length 10 centimeter. If the force required is 5 Newton, find the moment of force involved to turn the nut. Question is displayed here. Let's go and see the given statement. See what is given. R, which is your 10 centimeter, force 5 Newton, and they are asking us to find out your moment of force tau. So tau is equal to F into R. What is F here? 5. But what is R? R is given as centimeter. So 10 centimeter is equal to 0.1 meter. So I am writing it as such like that, 0.1 meter. So what is the answer? We'll be getting 0.5 Newton meter. This is what is problem number 2. Next, numerical number 3. Let me read out the question. The question is displayed here. A wheel of diameter 2 meter is shown in the figure with axle at O. A force F is equal to 2 Newton is applied at B in the direction shown in the figure. Calculate the moment of force about number 1 in the center O and number 2 at point A. Let's solve the problem. See, this is your wheel pivoted at the center. Then you have two ends A and B, which is of full diameter 2 meters, whereas the distance from OB is 1 meter. That is what is given here. Now let's calculate the moment of force at point O. Moment of force at point O is equal to, let's recall the formula, force into its perpendicular distance. That is equal to, what is force mentioned here? 2 Newton into its perpendicular distance at O is, it calculates 1 meter and 1 meter. So totally we have to take 2 meter into consideration. This is equal to 4 Newton meter. This is for moment of force at point O. They are asking us to find out moment of force at point A. This is equal to force into perpendicular distance. That is equal to 2 into 1, your 2 It's only 1, that is your 2 Newton meter. Okay, this is what is your third question. Next, fourth question, let me read out the question. A diagram in the figure 1.29 shows two forces. F1 is equal to 5 Newton and F2 is equal to 3 Newton acting at points A and B respectively of a rod pivoted at point O such that OA is 2 meter and OB is 4 meter. What should we calculate? We should calculate the moment of force F1 at point O, then the moment of force F2 at point O and total moment of two forces about O. So now let's calculate. See what they have given. We have to calculate first the moment of force at point O. So T1 is equal to F1 into R1. What is F1 here? 5 into your distances OA. Let me take this one at point O, F1. So it is 2. That is equal to 10 Newton meter. Now T2 is at point B. So T2 is equal to F2 into R2. Where what is F2? 3 into R2 is 4. That is equal to 12 Newton meter. What is the thing here? What direction it is rotating? Now 10 Newton meter, your first one is your anti-clockwise direction. So anti-clockwise direction, we give the sign convention plus only. Now for this, for the point B, it is moving clockwise direction. So clockwise is we give the sign convention minus. So it is minus 12 Newton meter, that is your clockwise direction. Now third, they have asked us to find out resultant moment of force or total moment of forces. For total moment of force, we have to add T1 and T2. So T is equal to T1 plus T2. What is T1? We have got 10 plus it is minus 12. So what are we getting? Plus into minus we get minus. So it is minus 2 Newton meter. When we are getting minus, we mean it is moving in a clockwise direction. So this is your total moment of force. Next is numerical number 5. Two forces, each of magnitude 10 Newton, act vertically upwards and downwards, respectively at the two ends A and B of a uniform rod of length 4 meter, which is pivoted at its middle point O, as shown in the figure. Determine the magnitude of resultant moment of forces about the pivot O. See, we have to find out moment of force at point A and moment of force at point B. Then we have to add the two forces which will get resultant force. Let's do it. See, this is the diagram which is pivoted at point O and the overall perpendicular distance is 4 meter, whereas AO is, this one is 2 meter and OB, this is 2 meter. This is your R1. Let me write it for you, R1, R2. Okay, so forces are 10 Newton each, acting at point A and O, A and B respectively. Now let's find out moment of force at point A is equal to F1 into R1. F1 is 10 Newton into R1 is 2, which is your 20 Newton meter. This 20 Newton meter is moving clockwise. Clockwise the sign convention will be negative. So, clockwise. Next, moment of force at point B. That is, B is equal to F2 into R2, which is, what is F2? 10 into R2 is also 2 meter. That is 20 Newton meter. This is also rotating in clockwise direction. So I am giving the sign convention minus. So this is also clockwise. Now they have asked us the magnitude of resultant forces. That is, your T is equal to TA plus TB. What is TA? We have got minus 20 Newton meter. So it is minus 20, this plus I am writing it here, and then TB is minus 20 Newton meter. So this is also minus 20. So this will be minus 20 plus into minus 20, which is your minus 40 Newton meter. Since it is minus, it is clockwise. Don't forget to write the direction also, clockwise or anti-clockwise, which carries half mark for your answer. Next is numerical number 6. Let me read out the question for you. The question is displayed here. Figure 1.31 shows two forces, each of magnitude 10 Newton, acting at points A and B at a separation of 50 centimeter in opposite direction. Calculate the resultant moment of two forces at point A, point B and O situated exactly at the middle of two forces. Let's do the problem. Now see, this is the diagram. Two forces are acting at 2 points. Let me take this point A and this as point B. Force is acting here. A is moving upwards and B is moving downwards. Forces are equal 10 Newton, 10 Newton. The distance between these 2 points are 50 centimeter. So these 2 points are pivoted at middle point O. So since it is in centimeter, I will convert it to, we want it in meter because the unit is Newton meter. So I have to convert this. 50 centimeter can be written as 0.5 meter. Yes? Okay. Now they have asked us, the given we have written, they have asked us to find out moment of force at point A. So let's do that. Moment of force at point A is equal to F1 into point A is what? Can I write it as OA or at point A? So it is R1. So that is equal to F1 is your 10 into 0.5 meter only. So you will be getting 10 into 0.5, you will get 5 Newton meter. Yes, this is your moment of force at point A. Next, moment of force at point B is equal to, so this is moving clockwise direction. So I am giving the sign convention minus. TB, that is moment of force at point B. So this is F2 into R2. F2 is also 10 into R2 distances. R is generally 0.5 meter, which is your 5 Newton meter. This is also going clockwise only. So I am giving minus sign. Clockwise. So we have got TA and TB. They are asking us to find out T1. So what is T1? T1 is equal to force into X. F1 into X. What is X here? I have denoted it x here. X, which means half of the total distance. So this is 0.5 means what is this? This will be 0.25. Yes, if this is 0.5, what is y distance? This is also 0.25 meters. So T1 is equal to F1 into x, that is equal to 10 into 0.25. So this is 2.5 Newton meter. Then T2, we should calculate T2. T2 is equal to F2 into y distance. So that is equal to 10 into what is y? This is also 0.25. 0.25, that is equal to 2.5 Newton meter. Then they have asked us to find out the resultant force. So here T naught is equal to T1 plus T2. What is T1? 2.5 plus T2 is also 2.5. The final resultant is 5 Newton meter, which is your moving anti-clockwise direction. And that is clockwise, sorry. Clockwise, the sign convention is minus. Clockwise. Since it is clockwise, the sign convention is minus. Next is numerical number 7. Let me read out the question for you. The question is displayed here. A steering wheel of diameter 0.5 meter is rotated anti-clockwise by applying two forces, each of magnitude 5 Newton. Draw a diagram to show the application of forces and calculate the moment of force applied. Let's solve the problem. They have asked us to draw the diagram. We have drawn the diagram. A steering wheel is of course circular, pivoted at point O. Then at 2 points the forces are acting. Let me take on one end it is A and on the other end it is B. At point A the force is acting downwards and at point B the force is acting upwards. Each of equal magnitude 5 Newton and 5 Newton. The diameter of the steering wheel is 0.5 meter. That is your R, perpendicular distance. F1 and F2 is 5 meter, 5 Newton. Then your diagram, steering wheel, and they are asking us to find out moment of forces applied. That is resultant of. For this we should know TA and TB. Moment of force at point A and moment of force at point B we should find out first. Let's do that. Moment of force at point A is equal to F1 into R. So what is F1? 10 into your R is, see actually I have this R is nothing but I can also write it as OA. So the 0.5 meter OA is only 0.25. So it is 25. So it is, can I write it as 1.25 Newton meter when I multiply this? Yes. Next, moment of force at point B. It is F2 into OB. That is, what is F2? F2 force, this is also, okay, 5. So this is also 5 into OB is nothing but 0.25. So this will be 1.25 Newton meter. 1.25, 1.25. Now it's right. Okay. Next, they have asked us to find out resultant moment of force. What is resultant moment of force? Is equal to TA plus TB. What is TA? We have got 1.25. So 1.25 plus what is TB? We have got 1.25. So 1.25 which is 2.5 Newton meter is the resultant moment of forces applied on the steering wheel. Next is numerical number 8. Let me read out the question for you. The question is displayed here. A uniform meter rule is pivoted at its midpoint A. A weight of 50 gram force is suspended at one end. Where should a weight of 100 gram force be suspended to keep the rule horizontal? Yes, let's do this for you. So what is given there? Weight W1, that is, this is your, first they have taken a meter scale. 1 meter is nothing but 100 centimeter. Yes, which is pivoted exactly at center, which means we have two distances, perpendicular distance R1 and R2. R1 is your 50 centimeter and R2 is also, the thing is, the other side is 50 centimeter, but R2 we don't know, we have to find out that. According to the question, what they are asking us is, one weight, that is 50 gram force is suspended exactly at one end, and the other 100 gram force, where should it be suspended? So if at all assume 100 gram force is suspended in the middle, what will happen? This side it will be of more weight and the ruler may turn this side. If in case 100 gram force is suspended exactly at this end, 100 gram is more, 100 gram force is more than this. So the ruler may turn this side. So where should it be placed so that the rule has to be horizontal is the question. For this we should find out R2 distance. R1 also 50 centimeter. I am not converting centimeter here because the unit of W is gram force only. So I am not converting it into meter. I am keeping it as such like 50 centimeter. Okay, fine. Let's do that. So according to this W1, W2, R1, R2, what are we going to formulate? We know that according to principle of moments, what is that? W1 into R1 is equal to W2 into R2. What is W1? 50 into R1. R1 is also 50, that is equal to, what is W2? 100 into R2, we don't know, let that be X. So X is equal to 50 into 50 divided by your 100. I am cancelling your zeros. So what is left out? I am left out with 25 centimeter. So this 25 centimeter should be suspended, this 25 centimeter from pivoted end, this 25 centimeter in a 25 centimeter distance, the 100 gram force should be suspended at right side of the pivoted end. If at all this one is like suspended, this 100 gram force is suspended this side, then the ruler may turn this side. Isn't it, as I already said? So this 100 gram force should be suspended right side of the pivoted end so that the rule will be horizontal. Next is numerical number 9. Let me read out the question for you. The question is displayed here. A uniform meter rule balances horizontally on a knife edge placed at 50 centimeter mark. When a weight of 20 gram force is suspended from one end, draw a diagram of the arrangement, number 1, and number 2, they are asking us to find out weight of the rule. Let's do this for you. So this is the diagram. They told 1 meter rule. So it is 100 centimeter. And it is pivoted at 58 centimeter. So I have drawn this. This is 58 centimeter. Okay, and a 20 gram force is suspended here. Okay, then they are asking what will be the distance from pivoted end to the end. It is 42 centimeter. Okay, so what is this weight we have to find out? That is your W1 we have to find out. And the R1 distance is, of course, from center to the pivoted end it is 8 centimeter. And the remaining is your 42 centimeter. Now two weights are being given, two distance is being given. We will obviously go for principle of moments. See, according to principle of moments, W1 into R1 is equal to W2 into R2. What is W1? W1 we have to find out, let it be X into R1 is 8, that is equal to, what is W2? 20 into 42. R2 is 42. In order to find out X is equal to 20 into 42. This 8 will come this side. Now substituting, this will be 4 and this will be 10. Again substituting with 2, 21, and this 2 again with this 10, 5. So it will be 21 into 5, 105 gram force is the answer. Is the 105 gram force is the weight of this one, the actual weight for the meter rule. Next is numerical number 10. Let me read out the question for you. The diagram shows a uniform bar supported at midpoint O. A weight of 40 gram force is placed at a distance 40 centimeter to the left of point O. How can you balance the bar with a weight of 80 gram force? Okay, let's do this problem. What is given here? This is your bar, which is equal 50 centimeter on either sides, which means it is pivoted exactly at center. Number 1, weight 1 is 40 gram force, which is suspended at 40 centimeter. So from the gram force to the pivoted end, it is 40 centimeter. And next, they are asking us, where should 80 gram force be balanced? Since it is more than this, if we keep it here, the bar may not be balanced properly. So they are asking us, where should we place this 80 gram force? So let's write the given W1 is 40 gram force, W2 is 80 gram force, R1 your distance is 40 centimeter. Now we should find out R2, that is your X. According to principle of moments, W1 into R1 is equal to W2 into R2. That is equal to, what is W1? 40 into R1 is 40, which is equal to, what is W2? 80 into R2 is X, we should find out. So X is equal to 40 into 40 divided by 80. I am cancelling this. So this 8, this one 2, and this one is 20. Simplifying. So what are we getting? This is 20 centimeter. So at 20 centimeter, maybe from here, exactly the weight should be suspended. 20 centimeter to the right of the pivoted end, we have to suspend this 80 gram force. With this, we will be completing the numericals of this chapter, chapter 1, force. In my next video, I will be continuing with the last part of this chapter, that is your uniform circular motion. Hope all of you will like my video. If you like my videos, please click like button,